everyone. So today I'm going to show you how to do the Gazebo simulation of PX4 quadcopter with 2D LiDAR in order to create a 2D map using SLAM Toolbox. Let's go. So first off, you will have to install all this setup file and pipeline that I listed here. Currently we are using ROS 2 rolling on Ubuntu 24. We also need to install the PX4 SITL simulations from the official repo, and we use MapROS as the communication middleware from the PX4 drone to the ROS 2 system. You also want to install the ROS to Gazebo bridge because we are simulating using Gazebo, which has been integrated in the PX4 source file, but you will need a bridge to send data from the simulation to ROS. Also, if you want to use SLAM, you will need to install the SLAM toolbox, and that's pretty much everything you need to install in order to run this system. In the process, you might need to install some additional firmware, for example like the RVS or some transformations tools to check the result, and just install it if you need it. First of all, I'm going to open the Terminator. You can also install the Terminator. It's just a because we are going to open a lot of windows, and I don't want to open 10 or 12 tabs of the terminal. So I am going to use the Terminator here to launch everything and the terminal to test. So after you clone the PX4 file, you will have the directory is PX4 autopilot. You want to access it, and you want to call the PX4 model as well as the Gazebo world. We have to use the LiDAR 2D because we want to make a 2D map using SLAM. So the command for calling the model with the LiDAR 2D is this one. As you hit enter, the world will spawn as well as the model. Nope, not this one. This one, okay. The system is loading, and here you can see the quadcopter with the LiDAR on top. This is predefined by the system, PX4 system. If you want to see the LiDAR, you can hit to the top right corner and search for visualize LiDAR and red reset. You can see that you have a 360, almost 360 LiDAR. And if you want to put the LiDAR into work, you can just put some obstacle here. You can see that the laser is being blocked by the LiDAR. And currently the Gazebo topic that is responsible for the LiDAR is world default something here that I will find later on in the ROS. Okay. Next up, you will have to bridge everything from Gazebo because this is the Gazebo topic, and you have to bridge it into ROS. So we will have to bridge using ROS to Gazebo bridge. This one. Here you can see that we run the bridge with the world default is the LiDAR topic in Gazebo with this type of data we want to the ROS with the same name to ROS topic. After doing this, you will have a ROS topic with the same name. As you can see here, I will try ROS to topic list. You will have a topic called world default something like this one, but this name is kind of long and I don't want it, so I will change the name using relay. Just copy the topic and change the name into relay. You will have a topic called relay, so I don't need to check anymore. So okay, but there is a big problem because in simulations we need everything to be on the same timeline, and if you just do this, then there might be a risk that the Gazebo and the bridge, the Gazebo and ROS using two different timelines. So in order to prevent all of this, I will first bridge the clock, which is the timeline of the simulation Gazebo here, and then only then I will bridge the LiDAR scan on it onto ROS. Oh, wait. Okay. Yeah. And also change the name, blah blah blah. Okay, let's check using ROS to topic list. Here you can see we still have the thing called word default, and we have the scan. Basically they are the same, just different name. I just copy it and here, and after that you can see that you have a word and you have ROS topic called scan that's responsible for the laser, and I might want to check for it using ROS. Let's call up ROS, and when you first open ROS it's going to be blank like this, and you want to add a new panel, a display one. Okay, let's add the by topic. We have the laser scan. Add the laser scan. Okay, let's also add the TF. I don't know why it's just so blank. I'll just open my old configuration. I will put the configuration file also on drive, maybe here. Okay, so nothing appear. That's weird. Okay, so maybe we are having the LiDAR scan right now, but we will need to, maybe we should check using echo. Not really need the ROS. Okay, you can see that the topic is running. Max range is 30 meters, and the frame ID, please notice this because it's very important, because we, in order to display everything on SLAM, we are going to need the frame to be connected, and as you can see here, the LiDAR frame is called link. Okay, please notice that. Okay, so next up we are going to open MapROS. After we have the PX4 quadcopter we have here, we need to connect the data from the flight controller to ROS using MapROS, and we are going to start MapROS with the simulation time. One small notice before you start the MapROS is that you will have to check carefully the MapROS. You will have to check the port of your PX4, because like these are simulations and everything is connecting to like virtual wireless port, so you will have to check that which port is your PX4 connecting to ROS. For example, you want to go to the PX4 tab and you type map link status here. For example, in my case, the MapROS is on channel in B. Instant 1, instant 0 is going to ground control. Instant 1 here. In my case it is 14580 and 14540. That's why my MapROS is I start my MapROS using this command. Here you can see you have to check it first. It's often instance 1 because instance 0 is the ground control. You will have to open the ground control right before, right after you open the PX4 simulations. Even though I have the use sim time equal true at the end, but from my experience, we should still try to force every node that comes from MapROS to use the sim time using a separate command right here. After doing that, you will have a lot of topic that come from MapROS. All this, but we are only going to care about the here the MapROS local position is the only thing we are going to care. You don't really need MapROS odometry because this is just for control, and this is the final thing that output from the flight controller, and you are going to need that. We might want to echo that for a moment. What happened? Oh, forgot the topic. Okay, you also see it's running. However, the frame here is baselink and map. Baselink can be understand that it's a drone. Baselink basically is a drone, and map is the world. Okay. So this topic is publishing the baselink and the map, which is the relative position of the drone to the world. So next up, we need to have another transformation, a static one, because you can see here that on the drone the LiDAR is fixed. It's not moving, or it's not changing its position relatively to the drone. So we would have a static transformations between the frame LiDAR or the link to the drone, which is base link, and we were doing that by this command. Here you see that I use base footprint instead of link, base footprint instead of base link, because in Islam the frame that of the robot is called the base footprint instead of base link. You really need to check the relative, and you want to be very careful on this frame, because just need to be a typo and everything will be disconnected. So now we can try to check the relation between everything using ROS to run TF2 tunes. Okay, view frame. Okay, it will run for 5 seconds, and you will have a map between everything, every frame that you currently have. Okay, it's exported, and you is 2311. Okay, here currently you have base footprint to link, base link, auto, and map. So you would like everything to be connected. I will show you an example of everything connected correctly. It should be like this. Here, map to odom to base link to base footprint to link. This is just also a static one, because they are just the same. So maybe I should change this one to base link just for reference, and I will change later when we do the SLAM thing. Okay, let's try it again. Another 5 seconds. Hope that something is connected at least. Okay, now we have base link connected to link, which is the thing we want. Base link to link, drone to LiDAR. Okay. Now our next job is to connect odometry to base link, because the job of SLAM is to connect odometry to map. And before doing that, I'm going to check with ROS. Open the config. Okay. Okay, let's change the fixed frame to link. You can see here that on the simulations we have 1, 2, 3 block. and here we also have 1 2 3 block. Let's try add another one. For example, like here you can see immediately appear right here. And if you change this to base link, you also get the same result because we are fixing the drone with the LiDAR. If you skip the step of relay, changing the name of the topic to from word default something to scan, you can just change the topic here. For the laser scan, you have the topic, you can change to word default. You see that it's absolutely the same, nothing changed. Okay. I said our next job is to how to connect odometry to baselink. And do you remember that when we try to echo the map ROS local position, hold on, we have the frame of map and baselink, which is directly from here to here. We don't want that. We want odometry to baselink and map to odometry. And that is the reason why we have to take these data from the topic and change the header, the frame. So I am going to run a ROS node. So in my ROS to workshop, I have a package called odom flattener, or maybe just like change the frame from map to odometry. Source. Yeah, okay. I will put the node on the file also. This one the job is to listen to the topic map ROS local position odom, and then change the frame. The original frame is map and base link. Now we change to odom and base footprint like this. Okay. And you have to install ROS and run this one. And okay. You have to build. I already built, so it's gonna be very fast. Okay, I will sort it. Okay, then I can run odom flattener. Okay, great. Now you are going to see that we are going to have a lot of frame here. Let's wait for 5 seconds. Okay. It's the newest one here. Here you can see we have the base link to the link and the odometry to the base footprint. So you remember that basically these two are the same, right? So we are going to connect the two using maybe another statics. I will just copy this one and change the name. We don't want base footprint and link anymore. We want base footprint and base link. Okay, let's check it again. And I hope that this time everything will be connected except for the map, because we haven't run ROS yet. Okay, it's done. Yes, odometry to base footprint to base link, the same to the LiDAR. You don't really have to care about the net and FRD. It's just some side product of map ROS. Okay, now if we open RViz, remember to try to reset the RViz when you're possible, because it tends to save the old data. So when you set the fixed frame to odometry here, everything will be shown. which is exactly what we want. Base link, still, map, nothing yet because we haven't started slam and link. One thing I forgot to mention that in order to drive the drone, for example fly it, you would have to install the ground control. This is quite different because it's an app image, and you will have to install it according to the download and install here by the instruction of the owner here. Just install the Ubuntu Linux and just run it normally. Okay, this is the thing that you use to control the drone. I will go to download, which is where I put it, and I will run it. PG. Okay. You will have a map of, okay, quite long, took a while. I will remember to put that in my document. Okay, you can see here, it's just a simulation, so the data, GPS data is generated, and you can see the drone like here, which is here respectively in the simulations. And for example, I will try to make it fly in circle here. You can change the joystick in the application setting. This is taking off, right? Why isn't it taking off? Okay, it's taking, okay, here, okay. I should just put it here. It's just low enough in order to see the obstacle. And I will make it orbit the place. Just click normally. No mission, please. Okay, orbit at the location. 2 meters is the minimum, but we should make it less than 1 meter in order to see the obstacle. Lower the areas, and okay, this will start orbiting at 3 meter, 5 meter, 6 meter. Oh my god. 7. Okay, I will try to reduce the altitude just enough to see the obstacle, maybe below 1 meter. Okay, you can see the obstacle now. That's good, just a bit more. Okay, perfect. Now you can see in Arvis, if you fix the map to Odom, you can see that the drone is flying here. This is the starting position, and this is the obstacle that we put in here. And you can see that the laser scan is changing with time also. And now we are going to turn on the SLAM thing. So SLAM is going to connect the map and odometry, and also make the mapping appear. Because if you put the fixed frame into map, you will see nothing at all. Because it's disconnected from everything. It's been isolated. No, not still so. Here, it's isolated. So Odom is the best friend now. Okay. We will turn on SLAM. Need to connect the map to the odometry, which is the job of the SLAM. And after you install the SLAM toolbox, you can launch using this command. We are doing online SLAM, which is SLAM directly when the things run, not just like record everything and do it offline. And then you need to use simulation time, because as I said, we need everything to be on the same timeline. And when you hit run it, okay, it seems running. Okay, let's check with the Arvis. I don't know why, but I cannot recreate this one. It's like too good. Okay, so you are setting here odometry. Let's turn on to map. Don't really need to turn on map anymore. Okay, so you can see here as the drone fly, it will map the environment, and along with time, and because this circle is kind of big, I will try to wait. Where's the cube round? Okay, I will try to push the boundary smaller, so it complete round faster. Okay, maybe I just kill the map. Maybe we should restart our list. Okay. Maybe I just messed up the odometry. Okay, here. Oh, you have to stop slam also. Okay. Let's restart slam. Wow. Cool. Cool. Everything dead. Well, I don't like that problem. You can map everything. Slam is not running, isn't it? Funny thing, huh? Okay, now everything appear on the map, and if you try to check with the slam with the frame view frame, you can clearly see the map right here already, but just to be sure, you can check with the frame, and you can see that the newest one here, 36, everything is mapped correctly, from map to odometry to base footprint and to base link to base to link to LiDAR. Sometimes in different system, maybe you're not using PX4, maybe you are using the same a real robot or something like that. The base is not like base link, and it's just base footprint, and you have to change your static TF accordingly. But as you can see here, the map is quite correct. If we try to compare it with everything we have here, you can see that is quite similar. Just 4 square and everything is clear. So maybe that is the end of this video. I hope that you learned something.